Okay, welcome everyone. Good morning or afternoon, depending on where you are. And welcome to the first session of the 2019 Cliff Grads webinar series, using modeling, life cycle assessment, and trade-off analysis to understand low emissions development options. My name is Meryl Richards, and I'm the science officer with the CCAFS Low Emissions Development Flagship. And we have several fantastic panelists this morning. And on the call is also Juliana White, who's the program manager for CCAFS. If you have any issues during the webinar, please use the chat box to communicate with Juliana. Can you all see my presentation?
Meryl, I cannot see it.
Okay.
Oh, now I can't. Now I can see your email. There you go.
All right, great, thank you. So this webinar series is designed to allow Cliff Grads Fellows the chance to share their research, to learn more about the science of low emissions development, to build research and career skills, and also to give you a chance to get to know each other. Our presenters today, who you will meet in just a minute, all undertook Cliff Grads Fellowships in 2018. And in addition to learning about the approaches that they've taken in their research on low emissions development options, you'll also have the opportunity to ask them questions about their research visit experiences. And I've asked them each to share one or two points of advice or lessons learned from their own visits that might be useful to all of you in your own research fellowships. So to introduce our speakers, as I mentioned, my name is Meryl Richards, and I'm the science officer with the CCAFS Low Emissions Development Flagship. We also have Abubakar Girei, who is a PhD student at Ahmadu Bello University in Nigeria, where he's studying the greenhouse gas implications of rice intensification and fertilizer management practices. His Cliff Grads Fellowship was at the International Center for Tropical Agriculture in Colombia. We'll also hear from Ridha Ibidhi, who's a PhD student at the Mediterranean Institute for Agricultural Economics of Zaragoza, and also works at the National Institute of Agricultural Research, both in Tunisia. His research focuses on environmental indicators of livestock production systems. And as a Cliff Grads Fellow, he was hosted by Bangor University in the UK. We'll also hear from Sebastian Vangeli, who is a PhD Fellow at the National Institute of Agricultural Technology and a PhD student at Buenos Aires University, both in Argentina. His PhD research is focused on the impact of agricultural management practices on nitrous oxide emissions. As a Cliff Grads Fellow, he was hosted by Rothamsted Research and Bangor University, both in the UK. Finally, we'll hear from Yohannes Regassa, who's a PhD student in agronomy at Bahidar University with a focus on climate variability and change and its impact on dryland agriculture in Ethiopia. He was a Cliff Grads Fellow at Wageningen University in the Netherlands, where he conducted research on water and nutrient management practices. So welcome to all of our panelists. There will be two opportunities today to ask questions and make comments related to the presentations. And that will be after the first two presentations, and then again after the second two presentations. I really encourage you to ask questions of the presenters, either about their research or about their experience as Cliff Grads Fellows. And you may do that by using the question box that you see in your little GoToWebinar control panel to enter your questions. If you're having any trouble hearing or using the question box, you may also use the chat box to communicate with the webinar organizers. And when you ask questions or comments, please, when you first do, tell us who you are and where you are visiting for your Cliff Grads Fellowship. And what we'll do is, after you type in the questions, you can type in questions at any time during the presentations or during the discussion. So if something comes up as you're listening to the presentation, please feel free to type in your question. And then I will read the questions aloud and we'll give the presenters a chance to answer them and discuss them. So we're ready to get started. I'm going to kick things off by talking a little more about this concept of low emissions development, what it means, and whether or not it's feasible, and then we'll hear from our presenters. So first of all, what is low emissions development? So there are two commonly used definitions. Simply, low emissions development means reducing agricultural greenhouse gas emissions while ensuring food security. And globally, we need to reduce agricultural greenhouse gas emissions by about 1 gigaton in 2030 in order to limit warming to 2 degrees, which is the goal set by the Paris Agreement. Some people also talk about low emissions development as agricultural development that increases food security without increasing greenhouse gas emissions. The distinction between the two is subtle. The definition on the left is about actually reducing emissions, while on the right is about just not increasing emissions. And that's an acknowledgement that it may not be possible or appropriate to reduce emissions everywhere, but we do want to at least avoid increasing emissions. Another way of looking at this is that low emissions development either reduces emissions or reduces emissions intensity. So reduces emissions per unit of agricultural production by increasing productivity without increasing greenhouse gas emissions. So where are the opportunities in low emissions development? This is from a 2014 study by Dickey et al., which really nicely summarizes the opportunities. And you can see here that the largest opportunities are in livestock systems, in rice management, and in fertilizer use, and also potentially in agroforestry and soils. And that's on the production side. On the demand side, there are also opportunities for reducing food wastage and for shifting diets that could have potentially large consequences for decreasing greenhouse gas emissions. So programs and policies for agricultural development are likely to be the primary platform for scaling up these solutions. But can they really do this? Does agricultural development actually deliver climate change mitigation? Does it reduce greenhouse gas emissions? I'll show you two examples. The first that you're looking at now is an analysis of the International Fund for Agricultural Development's portfolio from 2011 to 2014, representing about $5.6 of investment in agricultural development. Several colleagues and I conducted an ex-ante analysis of the mitigation potential of agricultural management practices that were promoted by IFAD's investments. There's a wide variety of practices that we studied, and some of the practices increased emissions, but some substantially decreased emissions. And you can see that the ones that really had an impact on emissions, and these were just practices related to crop production. We weren't able to incorporate anything related to livestock. But in crop production, use of organic fertilizers and agroforestry, and also some use of minimum no-till and other organic inputs such as green manures had the potential to actually sequester carbon in soils and thereby sort of compensate for greenhouse gas emissions. There was also potential in reduced irrigation of rice and some in system of rice intensification, which also deals with reduced irrigation of rice. So overall, the global mitigation potential of this program was 0.74 to 1.74 megatons of carbon dioxide equivalents per year, which is about equivalent to removing around 250,000 passenger vehicles from the road for 1 year. I'll give you another sense of that scale in just a moment. The next example is from the portfolio of the U.S. Agency for International Development. And this was an analysis that was done led by my colleague Julie Nash here at the University of Vermont and CCAFS a couple years ago. And this was also an ex-ante analysis of USAID's portfolio, but incorporated some other interventions such as in livestock systems and also landscape transitions, so land use change. And what she found was that the interventions promoted by USAID in some cases increased emissions by about 2.1 megatons of carbon dioxide equivalents, but there was also, through increased carbon sequestration and other interventions that reduced emissions, there was a reduction of 4.7 megatons. So the net mitigation was 2.6 megatons of carbon dioxide equivalents per year. So what does this mean overall? These programs show that low emissions development is possible. So the takeaway is that agricultural development as it currently exists is delivering low emissions development, but it isn't yet delivering it at the scale that's needed to meet the goals of the Paris Agreement. So the programs I showed you are delivering about 1 to 3 megatons of carbon dioxide equivalent per year per program. But that's only about 1% of the 1 gigaton that I mentioned that's needed in 2030. So we're getting there. Low emissions development is possible, but it's going to need a lot more effort to deliver the level of mitigation that's needed to really make an impact. So that's why I'm delighted that we have the largest ever cohort of Cliff Grads Fellows this year who are really pushing the envelope on low emissions development solutions. Our presenters today are going to discuss 4 different approaches to low emissions development: growing more rice with fewer emissions, improving the greenhouse gas efficiency of dairy production, improving our ability to understand fertilizer N2O emissions at a national level, and maximizing maize production and nutrient use efficiency to minimize greenhouse gas emissions. So I'll now hand the floor over to Abubakar, who's going to discuss growing more rice with fewer greenhouse gas emissions.
Thank you, Meryl. Okay, can you see my slide now?
Yes, you just need to put it in slideshow mode.
Okay. Is it okay?
Thank you, Abubakar.
Yeah. So can I go ahead?
Yes, please go ahead.
Okay. Yes. So my name is Abubakar Girei, a Cliff Grad awardee of 2018. I did my visit in Seattle, and we work on the project More Rice with Lower Emissions and Lower Water Consumption. As we observe, rice is a basic crop which has become more important in recent years, especially in the Latin America. This is reflected in the increase in per capita consumption of the crop more than any other crop in the region. And most of these crops are produced by family farmers. What do we mean by family farmers? Are farmers that are producing or cultivating a land that is less than 10 hectares in Colombia. Challenges, one of the most important is, or the most pressing of the challenge is the increase in climate variability. And this has a consequent decrease in the availability of water during certain stage of the rice production. As we know, rice use a lot of water, so any problem with water will be a problem for the rice producers. And most of these rice, like I said, are produced under traditional method of conventional flooding. And this is associated with negative environmental impact, such as increase in the emission of methane. And this is consequently making the crop one of the largest producers of methane compared to any other cereals. Specifically, rice cultivation is responsible for about 2,027 gigaton of CO2 equivalent emission in the region. So as a result, there is a need to come up with strategies to cope up with this problem of reducing the emissions from the current cultivation. So Fontagro is sponsoring a research on the topic which I presented in order to come up with several methods. And one of the methods, or the method that was suggested, is alternate wetting and drying. These practice include alternating period of flooding and dryness during the phases of non-critical growth of rice. This method has the potential of increasing the water use efficiency by reducing the water use by 23% and consequently also reducing the emission of methane by 64 to 87%. This kind of production method present a greater resilience of family producers to climatic variation. Now, continuous flooded rice production system to those of the two saving practices. We have the save alternate wetting and drying and the intense alternate wetting and drying. When we go to material and method, we'll discuss more on this. So the experiment was conducted in the Lagunas Experimental Station in the municipality of Saldana in Tolima, and the experimental design adopted was randomized complete block design, in which each of the block is having the three treatment, and the three treatment are severe alternate wetting and drying, whereby the plot will not be irrigated until when the water level is 10 centimeters below the soil surface, and then the mild alternate wetting and drying, whereby the plots of lands will be irrigated when the water level is 5 centimeters below the soil surface. And then, of course, the continuous flooding, which is always having water above the soil surface. So the gases will be collected from these plots, and then the concentration of the less emission, and then which one is given the highest emission. The rice variety that was used was Feather Rose 67, which is a lowland variety, and the planting method was direct sowing. Below is the layout of the plots that we use for the experiments. The measurement technique, collection of the gas samples were based on the chamber method, and the sampling of the emission gases was done in 15-minute interval. And the concentration of the methane and the nitrous oxide in each of the sample that was collected was analyzed by means of GC 2014 Shimazu gas chromatography in the laboratory of CCAFS. And then the fluxes of the gases that was collected was calculated from the rate of change of the concentration of the gases in the chamber headspace using a linear regression method and established by me, but I was not able to conclude the research. So I kind of did about 60% of the research and left. Then we are expecting the results from the people that continue in the research station. So we only have a kind of preliminary result. This is a result that is showing the emission of gases based on 31 days evaluation, based on the water treatment. If you can observe, you see that there is more emission, whereby the plot is continuously flooded compared to when the two alternate wetting and drying are employed. And you can also see that the emission is lower with frequent irrigation. To the left side is the emission from the methane, and to the right side is the emission from nitrous oxides. We all know how the emission is taking place for the methane, as when there is anaerobic condition, and then there is the existence of the microorganism methanogenic bacteria that will aid in the reduction of carbon dioxide that will lead to the emission. And for the nitrous oxide, the anaerobic condition will aid the denitrification process, thereby leading to the emission of the nitrous oxide. The second slide is showing the daily nitrous oxide based on the fertilizer application, because what we do in order to know the of the fertilizer application is that we collect the gas sample 1 day before the fertilizer application, and then the next 3 days, that is the 1 day after fertilizer application, 2nd day after fertilizer application, and the 3rd day after fertilizer application, in order to see the influence of the fertilizer. Now you can see from the slide, you see that initially, before the fertilizer is applied, the emissions were low, but at 1 day after fertilization, you see that the emission is very high. And then as the days keep on going, you see that the fertilization is, the emissions are reducing with the fertilizer application, then become stable. I think this is the only result I have at hand. I'm still collecting some of the results, which we are hoping to finalize by the end of the month. So even though the result is the research is not completed, but preliminary result from the result that you can see is that from this study, though it is not completed, but the water management practices that were adopted, that is the alternative wetting and drying, is an innovative water management practice that can contribute to the adaptation and mitigation of climate change in rice farm, and at the same time support a sustainable intensification of water management expressed in kg of rice produce per meter use. And then the advice to the fellow cliff grads that are coming to do their research is that cliff grad provides opportunity to connect with other researchers in the host institution, as well as researchers from other institutions that may be invited to do one research or the other, or present their findings on a research they are conducting. So my advice is you better use the opportunity very well in order to pave way for future collaboration, because you don't know your limits, as some of majority of us are academicians that are taking career in either research or teaching in the university. Also, it's a place whereby you have a lot of training, seminars, so make sure you use the opportunity to go to as many seminars and training as possible. And also use the research visit to create a frequent interaction with your host supervisor, your fellow interns, if they are available, and the institute, in order to enable you further develop your proposed methodology and ideas. Maybe most of us are working on one research or the other at home, so make sure you discuss with several experts that you are going to meet in the research institute where we are going to do your visit. They may either help in improving the proposal you are having or what you are working, and they may suggest some positive suggestion based on the work you are doing. Maybe you are encountering some problem. And also lastly, use the experiences that will begin during the research visit to enhance your core competencies, which are or may not have been addressed in your former research. So basically, this is what I have. Thank you.
Thank you so much, Abubakar. So we will now hear from Ridha.
Yeah.
So you can hand the presentation over to Ridha.
Yes.
I think, yeah.
I've just done that. Great, Rita. Perfect.
Thank you, Meryl. You see my slides?
Yeah,
Yes.
I can see.
Okay.
Yeah, thank you. Can I go ahead?
Yes, please do.
Yes. I am Ridha from Tunisia. I was awarded with the Cliffgrad Scholarship Program for the last year, in which I completed 6 months research stay in Bangor University, UK. During my research stay, I collaborated in the Ridha project, and my research focused on optimizing environmental efficiency of dairy intensification strategy for delivery of milk and beef in Costa Rica. In Costa Rica, milk represents around 12% of the added value of the main primary activity of the agricultural sector. In addition, Costa Rica set itself the difficult target for becoming carbon neutral by 2021. However, the dairy farming systems in Costa Rica face several environmental challenges, such as deforestation, climate change, and the expansion of low productivity pasture livestock production systems. Therefore, the main objective of these research studies are first to calculate the milk footprints of alternative dairy systems and intensification strategy using a conventional and attributional LCA approach, and second, to apply a consequential LCA to scenario of milk production, shifting from one type of dairy system to another to support the conclusion about the respective efficiency of dairy intensification strategies. As I said, the study took place using data representing multiple farms across Costa Rica. The information from the study came from data received from a survey conducted by the Ministry of Agriculture and Ganaderia, which is MAG, in Costa Rica, and another huge database, which is the VAMP database, the Veterinary Automated Management and Production Control Program, which cover around 20,000 farms of beef and dairy farms. The dataset covered a wide range of topics, including personal information of the farm characteristics, the productive parameters of each farm, milk production, the breed, the application as well of the fertilizer, manure, and economic costs and outputs of each farms. So we use those farms to develop typologies of dairy and beef farm as the first steps. After that, we use the Excel sheet and the key performance indicators. Sorry. And the key performance indicator considers are a global warming potential, the eutrophication, acidification, and the water scarcity as well. As you can see here in the bottom of the slide, the snapshot of the Excel sheet developed during my research stay. It's like to enter the characteristics of each farm types, like the number of animals, if the animal grazing or not, if they apply manure or slurry, the milk yield, and we get the outputs as the global warming or the environmental milk footprint of each farms. After that, we tested a different intensification scenario to assess the overall environmental efficiency of different breeding strategy to either minimize lactation, maximize number of lactation, or increase the longevity of lactation by comparing the environmental footprint of milk using the LCA tool of animal. We selected therefore animal with many lactation. We took on consideration animal with 7, 8 till 11 lactation, and as well we took on account animals with long lactation going from 12 to 18 months in those selected farms. So as a preliminary results, we identify 6 groups of farms, 3 for milk and 3 for beef. For the milk production, we identify the large breed-intensive dairy farms based in Holstein breed, the small breed-intensive dairy farms based on the Jersey breed, and the double-purpose farms, milk and meat, based on the Bosendicos breed. For the meat production, we identify as well 3 groups: the sucker beef farms based in Braham, the double-purpose fattening farms, which is based in Bosendicos, and the sucker fattening farms issued from Braham breeds. Regarding the LCA results, the results are still ongoing because we need to some data on feed composition. That the team now are doing that by collecting more data on the feed composition, which is really hard tasks. The expected result will help us to identify the most environmental efficient breeding scenarios toward the sustainable milk production, and in addition to identify the possibility to shifting from one type of milk production to another system more efficient environmentally and economically. As a conclusion, my main principal goal to join this Cliff Guards is to learn about the LCA methods, and I already took the advantage from the Bangor experience, and this task was achieved. Then I take advantage from a real application of the LCA tool on the Costa Rican dairy farming system, which is the project of a research paper that we're already working on. As advice for a future Cliff Guards student, please take the maximum advantage from the expertise of researchers in the GHG field, or the greenhouse gas emission field. From workshop, personally, I have the chance to go to Costa Rica and participate on the animation of a workshop on the LCA tool in Costa Rica for students and for stakeholders. In addition, set networking with other doctoral students and researchers in the host institution, which will be very helpful in the future. And to be honest, working in one of the most prestigious research centers on LCA, which is the Bangor University, and being supervised by leading scientists in the subject of greenhouse gas emission and collaborating with them in scientific publication is very, very extremely important for me. And that's all. Thank you so much.
Thank you so much, Ridha. So this is now an opportunity for all of the attendees to ask the presenters questions, or if you're working on research that's somehow related to what they're working on, feel free to also share what you're working on and how it might be, somewhat related. You can use the question box on your GoToWebinar control panel to enter questions or comments. So to kick things off, I have a question for Abubakar, which is, I'm curious if you were also measuring rice yields, or how you incorporated, understanding of the impact of the practice on rice productivity into your research project.
Okay, can you hear me?
Yes.
Hello. Yeah. Basically, like I said during the course of the presentation, we have to look for a method that is sustainable, because whatever we are doing, at the end of the day, we are targeting the yield. But we use the water stages at some point whereby that stage is not critical. Water requirement is not critical for the crop. That is, we explore those opportunities. And at the end of the day, we are going to see some yield parameters. We are going to see like the growth, the number of pillars per maybe a square centimeter. And then we are going to see the yield per plot. And then we are going to see the 1,000 grain weight. That will give us the quality of the grains with the what do you call it, the water management. So like I said, I only established the research up to about 60%. I believe by now they must have all the research station will have all those data when they are ready, and they will send it back to me. Then we now see if there is a correlation between the emissions and the yield. Is there an increase in yields with the adoption of the water management? So I hope I answered your question.
Yes, thank you so much.
Yep.
So Juliana has told me we have a few questions from folks, so go ahead, Juliana.
So I'll read, I have 4 questions here, and I'll read all 4 of the questions. So maybe we want to take notes. So Yuri has asked Ridha, how was dealing with farmers, and how did they react from the suggestions? So Ridha, if you could please take a note of that. Kofi Boateng, who is going to be visiting USDA Study Soil and Water Conservation, wants to ask, let's see, the first wants to ask Abubakar, if plot sizes matter in emissions research. So Abubakar, do plot sizes matter in emissions research? And Kofi had realized his plot sizes were quite big, 10 by 5. And did he use different chambers for the various growth stages? So those are 2 questions. So the next question, let's see. Samuel from Ghana,
please, can you come?
Just one second. There you go.
Meryl?
Samuel from Ghana asked. No, this is Juliana. Go ahead.
Okay, Juliana, please. I didn't get the second question.
Was that Abubakar?
Yeah, it's Abubakar.
So the second question is, how much do plot sizes matter? And did you use different chambers for the various growth stages?
Okay.
Okay, if you just take a note, and I'll go ahead and read all the questions.
Sorry, Juliana, could you repeat the question for me? Because I didn't hear
the
Rita, question.
How was dealing with the farmers, and how did they react to your suggestions? Okay, I'll continue. Let's see. From Samuel, and Abubakar, this is a question for you. Was there a baseline study of emission status before the research? So Abubakar, was there a baseline study of emission status before the research? Ranga Rarai asks, what did you do to analyze the nutrient use efficiency in the rice study?
Okay.
And Abubakar, what did the high variability show in the start of the experiment?
What, the last question, please?
What did the high variability show in the start of the experiment? And then those are all the questions. I actually, so why don't we, so Meryl, I'll let you do time management. Why don't we, if each of you could, Abubakar perhaps, or Rita, perhaps you can start, because I think you just have one question, and just try to answer quickly in a minute, and then pass on to Abubakar to answer his series of questions. Then I'll let Meryl take back over the facilitating. Go ahead, Rita.
Yes, thank you. Yes, regarding the question on how dealing with the farmers and how react with their with our suggestion. Yes, we have the opportunity to discuss in a workshop in Costa Rica with farmers how they can consider the transition from one type of farming system to another one with low emission. Farmers suggest that this transition should be like a subvention by the government, or in the subvention of the productions. If I will move from one production system and my production will be low in the future, so farmers suggest that they need a subvention for this project, for this production with low carbon emission or with low environmental impacts. So it's a little bit hard. We study already the physical hand, but as well we need to look to the economic hand, which is already still working in with another Cliff grads student there in Costa Rica. Yes. I hope that I respond to his question.
Thanks, Ridha. Abubakar, do you want to answer some of your questions?
Yes, please. Let me start by the first question, who asks, does the plot size matters in greenhouse gas emission?
Go ahead.
Yeah, it actually matters, but you know, we cannot the whole of the plots. Can you hear me? Can you hear me?
Yes. Please go ahead.
Hello. You know, we have two types of measuring. We have the static chamber, and the other one, the use of the instrument like AD covariance. So based on the plot what we use, we only take representative sample representative of a particular plots, and then we mount the chambers. But yeah, the size of the plots also matters. So if it is a big field, we use something like 80 covariance, and then we take the measurement. And then for the second question is different size of chamber used for different growth stages? No. What we do is that the kind of chamber we are using is a very big chamber that is surely above the height of our rice. The chamber we use has a height of 55 centimeter, and it also has a diameter of 25 centimeter. So you can see that from the starting of the rice to the harvest, the plant is not going to be more than that of the chamber because we use a bigger chamber. I think if you can refer to some Twitter handle, I think that was shared by Heidi Montgomery. I think you can see some pictures of me doing the greenhouse gas sampling. You can see the chambers we are using. If it is not available, I think I can share it through the Girei Twitter, and then maybe you can see the kind of chambers we use. Was there a baseline study of emission research before the studies? I believe before the starting of the research, there were a lot of researches in the research station by my host supervisor, Professor Dr. Ngoni Ridha. I think he must have the baseline studies before I do. But yeah, I'm not aware, but there should be since it's a research station. And then how do I measure the nutrient use efficiency of the study? Like I said, the research is more about water management and the less greenhouse gas emission. But like I said, at the end of the research, there is going to be some kind of analysis, the nutrients, the weight of the grains, the quality of the grains, and then sometimes even the biomass, the dry matter weight of the crops are going to be taken. So we can get some of the nutrient use efficiency there. And then the last question, if I get it well, it says, can I explain the high variability in the start of the studies? What does that mean? I think he is talking about the last slide, which I show, which is showing the influence of the fertilizer management that was adopted. Initially, when you apply urea fertilizer, the emission is going to be high. So, but we don't take the emission in the first day of the application of the fertilizer, because mainly what you are going to get in that first day is urea. So we leave it until the next day. So that is why you see the first day after the first fertilizer application, the emission is going to be very high. And then with time, the emission is going to reduce. So I think that is the cause of the variation in the first instance. So I believe I answered all the questions that was addressed to me. Yeah, that's all.
Thank you, Abubakar.
Thank you.
So I think we'll take one more question, and we have several more, but I want to make sure we have time for all our presenters. So if we don't get to your question, I will send it to the presenter it's directed to, and then we'll have them answer via email.
Okay.
So there's another question for Ridha from Ricardo. And his question is, in the consequential methodology for LCA, how do you manage the allocation between co-products? So Ridha, go ahead.
We already done the attributional or the conventional LCA already, but for the consequential LCA, we already not yet started this working on the consequence to expand the LCA approach, but the product that the allocation for the will estimate the milk footprint, the footprint of milk production, and we will allocate the surplus of milk as a co-product.
Great, thank you, Ridha.
Yeah.
Okay, so we're going to move on to our next two presentations, and we'll have more time for discussion after those presentations. So if you asked a question and we didn't get to it, hopefully we can get to it at the end. And as I said, if not, I'll have the presenters respond to your question via email if they don't mind. So before we get started, I'd like to ask you, Yohannes, could we just check your sound to make sure that we can hear you okay? Yohannes, if you could just turn on your microphone and see if we can hear you. And if not, please let Juliana know in the chat box. Okay, it sounds like that's not working, so we'll try to get your sound working, Yohannes. In the meantime, we're going to hear from Sebastian Vangeli about his work on data requirements to develop higher tier N2O emissions inventory. So Sebastian, please take it away.
Hi, can you hear me?
Yes, you just need to start your presentation.
I think the wrong Sebastian is the presenter, no? There are two Sebastians.
Oh, Juliana, could you please assign to Sebastian Vangeli?
Sorry about that. I just clicked on the first Sebastian I saw.
That's okay.
Go ahead, Sebastian Vangeli.
Can you see my presentation now?
I'm going to mute you.
Yes, great, thank you.
Great, thank you. So I'm Sebastian from Argentina, and last year, thanks to the Clifford Fellowships, I spent 6 months in Rothamsted Research in southwest England. So mainly my visit to Rothamsted had two main goals, and the first one was to understand the data requirements to improve N2O emissions inventory. So one of the goals of my research here in Argentina is to report N2O emission factors in scientific publications that could be used for the national GHG inventory. I work mainly on croplands like soybean, wheat, or maize from Argentina, which are fertilizer with urea, mainly, and other synthetic fertilizers. But we don't have any country-specific emission factors for the moment reported in scientific publications. So taking into account that Argentina has an important share of the global production of these crops, and that this activity is very important for our economy, I think we need to improve our inventories by having country-specific emission factors. On the other hand, UK has reported country-specific emission factors in scientific literature for their main agricultural production systems, and nowadays those emission factors are being used in their national inventory. So one of my purposes in my visit to Rothamsted was to understand the project that allowed UK researchers to obtain N2O emission factors and how they designed their experiments for that purpose. And that was the inventory project. My second purpose was to analyze UK data to develop further guidance on sampling duration to obtain N2O emission factors. Current IPCC recommendations are that emission measurements should cover a full 12-month period after the application of nitrogen to obtain an emission factor. But some of the UK experimental data might suggest that the majority of the emissions occur during a shorter period after application. So in this graph, we can see a figure that describes the results from a plot experiment from urine application in southwest England. And we have on the y-axis the net emissions, which are the emissions from the urine plot subtracted by the emissions from the control plots. And on the x-axis, we have the days from the urine application. And we can see that after the treatment is applied, there is an initial period of higher emissions in the urine plots, and after that, the emissions go to a background level. So in this case, we started to ask ourselves if it was necessary to measure during a 12-month period, or maybe resources were better deployed just by measuring a few months after the application. Using a shorter measurement period would reduce the costs and efforts needed to calculate new emission factors, which could be very important for developing countries like Argentina that don't have country-specific emission factors. So first, for my first purpose, I worked with the inventory project, seeing how this whole big project worked. So they did first establish the main climatic zones and nitrogen sources in each climatic zone. After that, they compiled all the existing plot experiments that had reported emission factors to that moment and established the gaps of zones and nitrogen sources where they needed to develop new experiments. And what was very interesting for me was to see how were the protocols of the plot experiments, to see how they performed the fieldwork, and to see how they dealt with the data to get the emission factors. So it was very good for me to have the opportunity to look at the protocols, to discuss them with the researchers in Rotterdam, to perform some fieldwork with them, and to work with the data. And I think all this experience will be very important for us to design and conduct experiments to get our own local emission factors. For my second objective, what we were doing was revisiting the sampling duration to get emission factors. And to do this, we are currently analyzing 102 plot experiments from different organic nitrogen sources. Most of these experiments were part of the inventory project that we were talking recently. So these experiments cover or capture a wide condition of soil and climatic variability existing in the UK and in Ireland too. And the design of these experiments include treatments with nitrogen application from organic sources and also control plots with no nitrogen added with at least 3 blocks. And the measurements were made from the day after application to complete a 12-month period to be IPCC compliant. So what we did was to calculate the cumulative net emissions for each experiment and measurement date. First, we calculated the net emissions by subtracting the emissions from the treated plots by the emissions in the control plots, as we can see in the graph on the left. That's an example for one experiment. And on the right, we can see the cumulative net emissions that we did by adding the net emissions up to different dates. That's the graph on the right. So these are the preliminary results of this work. In this graph, we can see on the Y the percentage of cumulative net emissions divided by the total emissions from the experiment from a 12-month period. And on the X, we have the days from the application. This is for 4 different organic nitrogen sources. And so we can see that cumulative net emissions grow from the application date until reaching 100% at the end of the experiment. But as we expected, the cumulative net emissions during the first months after the application represent a big percentage of the total annual emissions. There is variability for the different sources of nitrogen, and also the mean percentage for each state is quite different. But despite that, for all the 4 sources of nitrogen, the first months explain a big percentage of the total annual emissions. On this other graph, we can see the cumulative net emissions at 30 days after application. That's in the X-axis. And on the Y, we have the cumulative emissions at the end of the experiment. And what we can see is a very, very good correlation. This is really auspicious for us because we think it may be possible to predict the 12 months emissions just by doing measurements during a shorter period. So as conclusions of my work in Rotterdam, first, I would like to start with something positive, and it's that I learned about the experiment's design and data structure to develop improvements in GHG inventories. and I think I have now more knowledge to conduct an IPCC compliant experiment here in Argentina. On the other hand, something negative is I think to get our own emission factors will be very difficult, and I say this because we have a country that is 10 times bigger than the UK, and our budget for science is 10 times smaller. So I think we will have to be very efficient and thoughtful in the way we spend our resources, and to establish priorities in terms of GHG agricultural research. And finally, that the possibility of measuring during less than 12 months is very promising for developing countries like ours. So I think we need to work on this idea and see if it's replicable for other sources of nitrogen and regions with different climatic conditions and soils. And my advice for the future cliff rats is to enjoy mainly. Sometimes we work hard and we forget that we have to take some time to see what we achieved. So you are one of the awardees of this program, which is a great opportunity to visit the research center in different countries, where you will probably meet brilliant students and researchers. You will see new landscapes and different agricultural systems. So work hard, try to learn a lot, and generate long-lasting working and personal relationships, but mainly take some time to enjoy. Thank you.
Thank you so much, Sebastian. So let's test, Yohannes, let's see if we can get your sound working now, and if you can give your presentation. Can you test now? Okay, I'm sorry, Yohannes, we still can't hear you. I think what we'll have to do is skip your presentation for now, and hopefully we can incorporate it into a future webinar. I'm sorry about that. So let's go to questions for Sebastian, and then also if we have time, we can take some of the remaining questions for our first two presenters, Ridha and Abubakar. So I think we had a couple questions coming in. Let's go back to, there was a question for, another question for Ridha earlier. Or no, I'm sorry, this is another question for Abubakar from Titus from Indonesia. She'll be doing her fellowship at Bangor University in the UK as well, and continuing some of the work that's been done. Oh no, I'm sorry, this is for Ridha, not for Abubakar. So Ridha, this is a question for you. She asks, having said that milk production takes about 11.7% of the added value in the agricultural sector, I think it's a small portion. And how is dairy then really an important role in Costa Rica? And then she has a second question for Ridha, which is, how did you determine the strategies in terms of lactating length? So Ridha, if you could tackle those two questions.
Yes. Yes, regarding the milk production representing 12% of the additive value of agricultural production in Costa Rica, yes, that's true. That is a little bit low, but this sector is like many people work in the milk production sector, many smallholder farmers in this sector. Yes, the contribution maybe is low, but there is a lot of people that rely on the sector in Costa Rica, so it's very important for them. The second question is regarding the strategies, the strategy of the length of the, I didn't understand the question exactly. Could you repeat, Meryl?
Sure.
Meryl?
I'm just good.
Yeah.
Yes, let me just find the question here. It was about how did you determine the different strategies? So she's asking about the mitigation strategies in terms of lactating length. How did you choose those different lactation length strategies?
Actually, we chose those strategies from what we have as in the database, what we have in the database. I mean that we selected animals with minimum and with many lactation and with many lactation and with long lactation, and we assessed the environmental footprint of milk of those animals. Then we compare, for example, animal with 2 lactation or with 4 lactation and animal to with 7 lactation, and we compare the environmental impact of each animal with these characteristics. So strategies was based on what we have in the database. We have the database animal with many lactation and with long lactation. So is like a shifting from. So the advice to farmers in Costa Rica is to go to many lactation, for example, to go to 7 or more than 7 lactation, or to just keep their animal for 4 or 5 lactation and enough, and this environmentally efficient or not. Just to compare what we have in the database, and after that we recommend if farmers should maximize or minimize their length of lactation or the lactation intervals. Yeah.
Great, thanks, Ridha. So we have a couple more questions for Sebastian. From Girei, what are the methods and tools for data infrastructure and data management that you used? So Sebastian, could you?
Yes, thank you for the question. So mainly the methods were I worked with data from plot experiments that were developed, just like I said, with a treatment, with a fertilizer application and control treatment, and we having the data, we calculated our emission factors just by subtracting them and dividing them by the nitrogen that was applied. That's how we get the emission factors. And the tools were just, apart from the fieldwork, the tools were just simple, like normal spreadsheets. That's how we did all the calculation. So I think it's really simple. The difficult thing is to have all this data to be able to perform the calculations. I hope that answers that question.
Yes, thanks, Sebastian, but don't go, because we have another question for you from Raina. Do you have any comments on the patterns for different climatic zones in the N2O emissions in the UK study?
Well, that's quite interesting, I think, because there is some diversity in climate and in soils, and also in the date of application for the different amendments we analyzed. So we are currently going through this analysis, but we can see that there are some differences in the way that the emissions are getting accumulated in the time by the type of soil or the moment of application. But it's too preliminary, so I can't give you the results right now. But it's really a good question and something we are going to analyze in the near future.
Okay, thank you, Sebastian. And I actually had a question for you. I was really interested in the slide you showed with the trajectory of cumulative net emissions and how it differed by nitrogen source. And I'm curious why you think this is, and could it potentially lead to different measurement guidelines for different nitrogen sources? So, for example, for dung, you only need to measure for X amount of time, but for, say, compost, measure for X amount of time.
Yeah, that's also a very good question. And what we are doing now is seeing how we think that this may be related with the way in which nitrogen is, soil mineral nitrogen is available in the soil. So we are now performing this analysis to see if there is any difference between these 4 types of amendment in the moment in which the nitrogen is available. For example, we think that urine is available very fast in time for to be taken by the plants, but also to be taken by the soil microorganisms that produce the N2O emissions. So we think that maybe a key is in analyzing the soil mineral nitrogen, but also the quantity, the amount, the rate of nitrogen applied with the different sources is important. So we have to take that into account too. Urine has a big rate of application, which can have a big influence in the way that these cumulative curves are in the way they accumulate in the first months after application.
Great, thank you. So there's another question. I will actually take a question. Yohannes asked me a question about agroforestry. What is the formula to adapt an agroforestry practice by smallholder farmers? Who will decide what to grow, when to grow? Because in sub-Saharan Africa, farmers have less than 1 hectare of land. That's a really good point. And the agroforestry interventions that I talked about in the 2 examples that I gave, they varied a lot. I think most of them probably had to do with large scale adoption of agroforestry. So, by farmers that might manage a lot more land and might be managing degraded land, and, the use of agroforestry to actually recover and rehabilitate degraded land. In some cases, it might be expansion of or, use of productive tree species. So, commodity crops, such as coffee or cacao. But it really, I think it will really vary, and it has to be, the farmer themselves that decides, whether or not incorporation of agroforestry makes sense. With very small plots of land, it might be, a couple trees as hedgerows, or, maybe agroforestry doesn't make sense at all. With pastoral systems, it might be species that can provide fodder for livestock. So I think there's no one-size-fits-all formula for agroforestry. And then I have one more question here. This is directed at Ridha, but it really could be any of the presenters. It's from Danielle Matzenbacher, who's from Brazil and is doing her research stay at the Swedish University of Agricultural Sciences. And the question is, can you briefly comment on whether you had difficulties in getting cooperation for data collection? And that's a question for Ridha, but if any of the presenters would like to address that, that would be great. So Ridha, maybe you can answer first.
Yes, actually for data collection, yes, we use it already exist databases, but access to those databases is really a challenging point, because we found in those databases a lot of errors and a lot of not real data. So to discuss with experts from, for example, the Ministry of Agriculture in Costa Rica about the reality of if those data are reasonable or not is really very hard, because they say farmer enter their data in the databases, and anyone can know if this data is true or not. So we spend a lot of time checking those data and calling farmers about the credibility of those data. So, and actually in the beginning, we started working on the LCA analysis of the UK farming systems, but it really took a lot of time to get access to data. So we select only Costa Rica, and when we select Costa Rica, there is a lot of error in those databases. So I guess this is a very, very challenging point for us. I hope that I respond to this question.
Yes, thank you, Ridha. Did anyone else have challenges in cooperation for data collection? For example, Abubakar, were you working directly with farmers? I know you were working with federos. Were there any challenges that you encountered, and how did you deal with them?
No, I didn't encounter any challenges. In fact, they were very much cooperative. And whatever I need, I just get it with the federal people, the climatic data. And no, I don't have any problem. I think the only problem I have is communication because they speak Spanish and I speak English, but I was able to, but that's the only challenge. Yeah.
Okay, great. Well, that's good to hear.
Yeah.
Thank you. So we're almost out of time. So
Yeah.
on that note, I want to thank you all so much for joining the webinar. And this, as I mentioned, this is part of a series. So this first webinar was on understanding low emissions development approaches.
Yeah.
And I hope you'll join us for our next webinar, which is on direct measurement approaches to investigating mitigation options in livestock systems. So we're going to take a deep dive into livestock systems. There were 4 Cliff Grads Fellows in 2008 who've been involved in really fascinating research on reducing emissions from livestock systems, and I'm really looking forward to hearing about their work, and I hope you'll join us for this second webinar. At the end of the second webinar, I'll also discuss some tips and tricks for writing and publishing journal articles, which was a topic that previous Cliff Grads Fellows found really helpful at our 2017 workshop. So thank you so much to our speakers, and I hope you all have a great rest of your week, and we'll see you next week.
Yeah. Thank you so much.
Thank you, everyone.
Thank you very much. Thank you.